Okay, so the question is telling us to form a 4-digit number using the numbers 2, 3, 5, 7, 8, and 9. But here on part 3, the condition is they are asking you to form them as odd numbers that are greater than 7,000. So to better visualize this, we have 4 slots for 4 digits, and odd number means to say that the ending of this 4-digit number should end with either 3, 5, 7, or 9. And numbers greater than 7,000 should start with either 7, 8, or 9. So we're looking at 7,000s, 8,000s, and 9,000s only. So if you look at the numbers in the beginning and the end, there's a possibility that 7 and 9 can repeat. So we have to come up with a few case scenarios to avoid this repetition. So in my mind, I have 3 scenarios that I can think of. One is the odd number that starts with 8. Number 2 could be an odd number that starts with 7. And the third case could be an odd number that starts with 9. So from the pool of 6 numbers, we pick 8 and fix it in the beginning. And towards the end of the 4 digits, we are limiting ourselves to only 4 choices to pick from, which are the odd numbers 3, 5, 7, and 9. So there, for that slot, we actually just pick 1 out of 4. So after you have picked the number 8 and a random odd number to fill up the front and the back, you are left with 4 other numbers to fill up the gaps. And you have 2 gaps to fill up, so meaning to say you take 4p2. So for the calculations of this case, you have 4p2 times 4p1. 1p1 equals to 1, so I'm not going to write that down, and that equates to 48. So starting from case 2, it's starting to get a little spicy, whereby if you start your 4 digits with 7, you are not supposed to end it with another 7. They're not allowed to repeat. So to visualize this again, we're just going to have 7 as the first number, and to the end, we are limited to only the numbers 3, 5, and 9. So those 3 numbers, we're going to pick 1, so that's 3p1. The fixed number 7 is 1p1, and of course, the 2 gaps in the middle is filled by 4 other leftover numbers, which is 4p2. So finally, the calculations again, we have 4p2 times 3p1, which is equals to 36. For the third case scenario, is almost like the second case. So if we were to start our number with 9, we are not supposed to repeat it at the end. So towards the end, we have a selection of 3, 5, and 7, and we're gonna pick 1. So that's 3p1. 9 is 1p1 again, and the gaps is of course filled as 4p2. And so the calculations will be the same as the second case, which is 4p2 times 3p1, which is equals to 36. So at the end of the day, to find the total number of odd numbers that can be formed more than 7,000, we add 48 to 36 to 36.